Now our next lecture will be in English and by Jakub Marszałkowski, and he tell us about AI assistant recommendations in development. So please welcome.
Good evening. Thank you for coming. And coming and coming. Okay. Let's go through the boring stuff then. Introduction, who I am, what I am doing. Yeah, you might maybe know me from some of the work I'm doing for the game industry. Organizing a conference in Poznań, one of the biggest in Europe, and also I work with the Polish game industry, trying to help developers to bring them places. But my other job actually is at Technical University. I have PhD in computer science, yes, indeed, in two-dimensional packing. I did PhD on two-dimensional packing. Let's not go in there. Now I'm touching more of topics like researching some machine learning-based tools to speed up game development, to achieve more in game development. I'm also teaching one-on-one on game design at Technical University in Poznań. What I will be showing you today was produced together with a company called Ice Code Games. I worked with them for a few years. We're running two research projects. The second one is in the middle right now. The first one is closed with some success and I will be presenting what we've developed there. I do like them as company because they start as small indie and every game they produce is better and has better scores. You've maybe heard of the Hardwest 2. What I will be showing here today was mostly developed on the course of Hardwest 2, and they also recently released Rogue Waters, another top-down strategy game. There is maybe some not that happy message about publishers. They don't have luck with publishers, so some of their efforts were eaten by publishers, but this is what I think is happening to the industry in more places. So the tool I will be showing today and the research I will be showing today was developed on the course of production of Hardwest 2. It's quite well received, top-down strategy, tactical turn-based game. Some of those aspects will be important for us later, like the game is using grid to design levels, which was helping us on the course of this tool as well. So what is the project that we actually developed and what brought us to work on that? In the game industry, we are in a specific place where the market, the gamers demand better games, games of better quality, games of bigger scope, games that are providing more of gameplay, and they want constantly more and more and more. And what is maybe also difficult, when gamers will be rating your game, for example, on the Steam, they will not check how big team are you, what budget you had, no. They will compare your game to Assassin's Creed, even if you were 10 people team and you only had 1 million of budget in head instead of 100 millions of budget. So that's the new game market that we need to produce games to. And we see better tools, AI-powered tools, as some possibilities to be able to catch up with the bigger studios, to catch up with the bigger games, to produce more game, to produce better game on the same budget, on the same time budget, on the same money budget, and so on. So we believe tools like the one we developed could help with that. Many tasks that are done in the development are repetitive, and any automation with those repetitive tasks could help. There are hundreds of micro decisions that designers need to make every day. This is somehow important for us because in this project we were focusing on those decisions that designers are making, and the tool was supposed to help those designers in those decisions with some recommendations. So by easing them some time of those hundreds of micro decisions, maybe we can help them with saving some time to focus on some more difficult matters, and they could deliver more quality elsewhere, or they maybe could do more work in the same time to produce more. This was our goal here. So yeah, well, how can we try to use AI or machine learning? Usually it's machine learning recently to do the job here. There could be a lot of data from the game that we are producing that we could use machine learning to be trained on. I will explain on that later. But the approaches that we mostly see on the market, like the generative AI, we don't have that much control on that. We ask it to do something, it is doing something, we like it or not, we ask it again, we ask it to improve it, to fix, yeah, maybe in the end we will have the results that we want, but it's often not that great. So we tried to do something different, something that will not take people's jobs, but help them to do jobs better. So we went to non-generative. The fact is that we actually started researching this way before the current boom on the generative AI. That's maybe another learning. The scope of those projects is quite long. We started thinking on that in 2018. In 2019, we submitted a request for grant. We were given grant almost 1 year later, and then it took us almost 2 years to do research and development of that. So it takes time. We started before current wave of generative AI. Also, what is funny here, where we were designing that, we were quite scared that we will be too late to the market with what we were trying to do. We did research on on what some other big companies are doing in this AI recommended areas, and we found out that at least several big game producers are developing some systems that should give recommendations to programmers, should give recommendations to designers. So back then we were like, oh, we're so scared, we will be too late, everyone is so much ahead of us. And as of today, everyone is doing generative AI, no one is doing this recommended approach. So yeah, we are completely not too late with that. So we decided to go with an approach where the AI is giving suggestions. It's based a little bit on the recommender systems. You definitely have seen some recommended systems somewhere. Definitely in e-shopping, you buy one product and the system is, hey, the people who previously bought that product also bought another product with that. So that's the basis of the most basic recommender algorithm, and it's happening everywhere. What is maybe closest to what we were trying to do, to what we were trying to achieve, is reading auto-completion. So you have some text written and the system recommends your next word and next word and next word, and it kind of sometimes works there out. So we tried to do that in game design, in game, three areas of game design. I will show you on short demo first of them. That will be probably the best approach to explain what we did and what we achieved. So let's see that. That's hardware to one of levels in level builder in Unity, and this is how the level is looking in the game. The level is divided to sectors, as I said. The sectors can be occupied by characters, characters can do actions. And if level designer is selecting a sector, a drawer with recommended assets to be put in this sector is displayed. So based on what the machine learning was able to learn from the previous levels or from the rest of this level, on further building of this level, it will give some recommendations. Yeah, you are looking at some sections with stones and bushes. Hey, here are some cool stones and bushes that would maybe fit that place. And in fact, they will always, not always, they will often fit that place because maybe you want to push another bush. And instead of looking for that element in the long library, you could take it from the recommendations drawer, and that could be faster. So if we would go in a moment to a saloon and we would put a table there, the system would be like, hey, previously on tables in saloons there were whiskey bottles and glasses and cigarettes and coins, and maybe you want to put something else, you can do that still, but using the element from the system could be faster. We can pick different algorithms that are doing recommendations here. I will get to that in some basic details in a moment, but this is in generality how it works in the system. So how have we built that? Actually, our original idea was slightly different, and it shifted a bit during the research. We wanted to do more like systems design tool. We wanted this tool to be able to recommend in many other places. We made this decision that everything in our game will be game objects. Yeah, very original. But it was having some consequences with that. Like all game objects were supposed to have tags. Tags were defining those objects, defining what's on the objects, how, for example, characters are dressed, what items they have, or what abilities they have, what mechanics can they use, what scripts will be launched. So everything was supposed to be driven by those tags, connected with those tags. And then on the base of that, we could look for some similarity. If two objects had similar tags, they were for some reasons similar. Actually, the abstract painting on the right side is how at some stage Hardwest 2 was looking in a browser that we built. Every dot is an object, and those arches are connections between those objects. So if we can have objects with tags, we can recommend tags to future objects. For example, we designed already 3 units in the game: Cowboy, Gunslinger, and Explosive Specialist, and we are designing the 4th one. So yeah, new unit, Sheriff, and we've chosen that it will be a unit, so the system can see, hey, if it was a unit in the past, it often had hat. So maybe you would like hat to it. Yeah, super simple example, but it was also working on bigger scopes, or on bigger ideas like this. And we've tried to put that to 3 actual applications. This game objects designer that was supposed to be able to produce characters, enemies, NPCs, all that kind of stuff. Do I have laser pointer here? Not sure. That's on the left here. We also tried to put that to narrative designer to be able to do some recommendations in narrative designer on base of previous dialogues, on the base of previous narrative interactions. And the 3rd one, it's the one that I showed you on the video. We tried to put to use to use on the levels designer. The technical scope of that was on game being built in Unity. We had some editors built in the Unity, but then we had wrapper that was bringing to REST API some recommendations from recommendations module that was written in Python. This was important decision because in Python you can find plenty full of libraries that will allow you not to program, not to code all the algorithms you need from the scratch. On such projects, you rarely really create new algorithms. Usually you adapt some existing algorithms, you put them to use to the cases you have. So what we tried to build here. We tested a bunch of algorithms. It was scientific approach, so yeah, we scientists like to do trivial algorithms as a baseline. It's like, yeah, it's a thing that we always do. Why? Those algorithms give usually terrible results. So if your real algorithms give worse results, you see there is some big problem for that. So we built something very trivial, and then we tested with that other algorithms we had. I will explain some details on those in a moment, and also I will explain the algorithm stacking a little bit that we tried to do. So the first and maybe most obvious thing we tried is a priori algorithm. It's algorithm that is most commonly used in those recommender system. It has several advantages. It's simple. It builds sets of items that are commonly used. You can also browse those sets, which is sometimes useful. It works quite nicely on low amounts of data. I think from the algorithms we tested, this one was least data hungry, so it was able to produce decent results on very early stages of game development. And actually we need that. You cannot go with in such projects only with algorithms that are requiring lots of data to work, because you will have early stages of game and you want your tool to work there as well. You will have early stages of levels and you want your tool to be able to learn on this level only, to be able to provide recommendations of this based on learnings from these levels and not necessarily from other levels. So if you use only data hungry algorithms, there will be problems. Also, in a priori, what is nice, it's that it's possible for humans to track what the algorithm is doing. Like most of the other algorithms, we should consider them as black boxes. We put some data in, the algorithm is doing something and is giving some responses. But why actually those responses? This will be often very difficult for humans to track, because there is too much happening, too much levels, layers on unobvious calculations. On a priori, you can track that and you can test with it what's actually wrong in your approach, where are some bugs. So this was serving us those needs as well. Its biggest weakness, it's exponential. The times it needed on bigger data sets were absolutely not acceptable. Even running it through entire night would be probably not enough to get decent results. You can obviously stop that by some limits of data processed or by some limits of times of processing, but then you are getting worse results. So we definitely needed to look further for better algorithms to allow us to achieve more. Our next approach was logistic expression. It was quite nice all-rounder, and it was serving us quite long in the development, because this was a process. We were doing that over 2 years. So for quite long time, it was the algorithm that was providing us the best results, but it was finally beaten. Honorable mention probably should go to naive Bayes, because it was giving quite decent results, even if it was the fastest algorithm, and in many cases we could run it on linear complexity. But it was not giving the best results. It was good for some quick checks. It was good for testing. We had better results with other algorithms. The biggest disappointment we had among algorithms was word-to-vec approach, which seemed like perfect fit in the beginning, because it's the algorithm that was supposed to work with words. So our tags are words that should go fine together, but we were not able to tune it to get decent results. And the final conclusion is that it's rather working with some body of text. If you have several acapits of text, I don't know, 1 page of text, it will behave decently. Maybe tags are too short for it, and it was not able to provide good results. And in the end, among the algorithms, what we found as best fit was probably the random forest. It was taking some more effort to prepare it, to tune it. Actually, we've spent some months tuning it finally. It was super data hungry. It cannot work on several objects as the a priori algorithm was able to. But in the end, in the cases where we had enough data, random forest was giving us the best results, the best quality of recommendations. So here we have some visual comparisons of a priori and random forest on forest setting, actually. The designer is trying to add some elements to this forest sector in the game, and a priori is giving some most obvious recommendation, but the random forest learned that there was some cooking device at the fireplace in forest last time, so maybe that would be another place for that, and some other elements that were there. So we decided that in those drawers, the designers will be able to choose the algorithms, because sometimes one might be better, or on the other cases, another could produce better results. So that's the end results after placing what the elements were, what the algorithms were recommending, and as you can see, it's looking a little bit different. Stacking was introduced to us to solve this very old problem of not every algorithm being the best solution for all cases. So like in games, you could have this shotgun versus sniper rifle problem, different outcomes, different situations when you would like to use those. So also, and early game versus late game. So we had similar problems in the development of the tool that we were building. Early stage of game, late stage of game, different results. So we decided to try to combine some algorithms with stacking. We did some training on some stacking, and with that, in most cases, we were trying to merge results from algorithms that were giving results that were most apart from them. So for example, that was sometimes a priori, and for example, linear regression, yeah? Not necessarily the random forest. And in many cases, this was giving better results as well. That's the usual thing that scientists do when they want to compare results of some algorithms. Yeah, we do charts that are difficult to read. There is a logarithmic scale on the time axis here, and there is quality. That's one of the charts. As you can see, some of the algorithms were often behaving similarly on the time scale, but were giving different results. I'm not sure if I will be able to show that here, but for example, the word2vec that we have here is dominated by nearly every other algorithm. You can have better times, you can get better results, and you can get better results in better times. So yeah, that was one of the charts that decided on dropping those algorithms that were not exactly efficient in this approach. So what could be recommendation here for quality testing of those algorithms? For the early cases, for the beginning of the project, we tried to test on some small cases. We did like test levels. The test levels were not really big. The one that you can see here, it had only 10 game objects and 68 different tags. So the a priori algorithm run on that was working, was giving decent recommendations, or was even giving good recommendations, but it was not very useful. The scale of the level was small enough for the developer to be able to find out all those recommendations by himself. The game was too small to benefit from such a tool. So here's maybe one of the general learnings that we had in this project. Tool always have some overheads. Maybe construction of tool will take you more time than the benefit of using this tool in the case where you will be using it. So this was too small, too trivial. We had to move further. So with that, we moved to testing with users. This is always more difficult. At the very beginning of project, it will be often not possible. It's slow, it's costly. You need to ask testers to do the actual testing. You need to compare the results. You need to find some objective ways of measuring that. So we tried several times. We were quite unhappy with results, and we decided to go further to some more automated testing. So we needed a metric that would allow us to compare the results of those recommendations in those cases where we have them. And we needed a way to produce data sets for this automated testings. So we took some available data sets. At this point, we already had some data from Hard West game. You can see such a data set on the left side of the chart. And then we were creating test cases by removing items from those. If you do that properly, it's quite efficient. efficient because you can remove different items and create different test sets with that. And then you can build recommendations. You can train them on training set, and you can test them on testing set if you keep the separation properly and with metrics like precision at K, so how many items were proposed and were they high enough on the recommendation list. You can have results that will tell you, is this algorithm actually recommending better than the other one? And we did plenty of that on different data sets. Another interesting problem here was where to get enough data for testing. So yeah, we created our own data sets like this test level that I showed you, but it was too small and not sufficient. So then we moved to tools that were creating us the test sets, and there were problems with some of the test sets produced by those tools of not having the distribution of elements that would be in the actual data. That's very important with tools that produce test set, that you keep the distribution of the elements proper. If there is something that is, I don't know, normal distribution and you do power law distribution, or the other hand, yeah, you're not gonna like the results. It will be completely false. We also worked a little bit on finding some data sets from the internet. There are, for example, ready-made levels on open source games that you could use. There are some, we even tried the approach with the game mechanics designer, the approach where we tried to use the game design books that are in the internet for the old games. There is quite a number of those games design books released, and we were trying to recodify them for our tool to be able to learn on them and do some recommendations on them. But in the end, it proven to be too much effort. Those were not that well structured. Those were often a text, so it was difficult. And when we were in the middle of the process, the big chunk of data from Hardwest finally was available from the development team, so we decided to use that instead. Obviously, when you use data from the internet to do any learning of machine learning, yeah, be careful. If you are actually allowed to do that, there are always problems with that, or possible problems with that. So in the end, most of our tests were done on exact data sets from previous games we had, and this actually worked. Okay, so what three applications we had there? First of them would be the level design tool, which proven to be most efficient one, also because it was easiest to build. It did not require this actual tagging. So here our machine learning was able to learn from what was on the level actually. It required not the overhead of work of designers to use the tagging, because this tagging costs some work. Yeah, it will probably pay off at some point, but in the beginning it costs some work. With the level designer, this was easier. We could read the levels, see what's near, see what's on the same sector, and with that we could achieve good results. It was also very intuitive. It was not requiring any learning from the designers. They were just sitting to the tool. The drawer was showing recommendations, and they could use them to put the elements in the game. It was quite universal. The approach we have, we believe, could work on 2D games, 3D games, and some other approaches. We've measured on some tests almost 30% of productivity increase on level designers. So that would be actually quite nice. There were some problems in the early approaches. The grid the game was using originally was too slow. So it was creating these borders or JPEGs effects that something did belong that side and not that side, and things were quite messed. So in the beginning we solved that by increasing the grid. Yeah, it was quite decent, but then in the end we developed quite complex solution with a walking frame that is moving through the level and is taking several measurements to see what's together, what's close to each other, to learn those relations between objects on the level. Defining game objects with tagging and then recommending tags to other objects, and with that some features, some scripts, some items on characters was developed and tested, but it did not work as great as we originally imagined. The overhead here was quite significant. The tool was not that obvious to use, and also, as you can see, the interface. Yeah. This could have better interface. The one you see is definitely not great. But it was working, probably could be improved to be working in practice on future games. And the third tool, the narration tool, that was the most difficult and least successful part. Probably not by not being possible to achieve, but by the game having not enough narrative content. So yeah, it worked. Yeah, you could use that, but game was having too few dialogues, in fact, to benefit on that. Maybe on something way bigger, like huge RPG, you could use that approach, but not in that game. So if you'd like to try something like this yourself, identifying good application is the first step you should take. You need easy to process data. You need to see what automation will cost you and what will be the benefits of it, and preferably build on existing processes. The process of tagging that we were trying to include was too new and too off and too difficult to explain, so this was bringing some limitations. Yeah, research projects. There are paths, there are bumps, there are dead ends. We had several. The biggest problem through entire course of the project was data and data and data, and every week we were discussing data. It was either not enough, not good enough, too much noise in the data, not enough noise in the data, always some problem. In the end, we fixed that, we solved everything, but it costed a lot of effort to go through that. What's also quite interesting, at least for me, we tried two approaches. I'm talking to you about machine learning for past half an hour, but we also tried graph approach. Actually, in the original grant that was given to us, the graph approach was the main approach, and the machine learning was like, yeah, maybe. So we spent quite a lot of work on this graph approach. We did some beautiful graphs. Not sure if you agree. I do believe those are beautiful. And we had actually almost no results with those graph approach. So if there would be in the grant no second chance on machine learning, the grant would probably fail. But then we had this machine learning. We had quite quickly good results with that, and we were not able to build anything on those graphs. So yeah, let's skip those graphs and do the machine learning as long as it is working. So what would be the key takeaways from these projects? So we're scientists. We would love always to discover something that explains universe, humankind, and something very general. We did hope in this project we will be able to find some general findings on how game designers work. Maybe unroll some processes, be able to describe them, and no. Our hopes are usually naive and we don't get that. But we had one quite interesting general finding, at least interesting for me. If you've been on my previous lecture on Games Gathering last year, you maybe remember me talking about curves. So yeah, curves again. So we found out, and it's one of my favorites, so power law distribution. We found out that actually everything in the game we designed was following the power law distribution. In the beginning, tags were following power law distribution. How does this work? This distribution says that there are some tags that nearly every object uses, or really many objects use. That's the left side of the graph where it goes really high, and we see something like 160. That was, for example, a tag in the game that was used by 160 different objects. And on the right side of this chart, we have long tail of tags that were used by 1, 2, or in other way, very few objects. So these are rare tags. And it turns out this is how our games are built. I know. When I said it, it's obvious. But I think maybe no one said that before. Yeah, there are tags, so game mechanics, items, scripts, features that are on numerous characters and items that are in the game, and there are those that are really rarely used because they are, I don't know, on bosses, on a character that is in one specific location, or something different. So it definitely works that way. It also works the other way. There are objects in game. That's one of the charts on the bottom. I don't see it that well here. There are objects in games that will have dozens of tags, so dozens of abilities, scripts, items, and there will be items in game that will be having one tag. Hey, I'm a rock, I do nothing, yeah? I just lie here. So that's another way how this power law is working here, and yeah, I'm kind of fan of that. Then we could have some quite general takeaways on AI, machine learning, for example, in this recommendations approach. So yeah, there is definitely more AI ML than generative AI ML, and I do believe that the boom that we have now is not that great because we are not doing some research that we maybe should doing. Maybe we should look broader, and investors work in that way that they all follow one path. So it's the moment where it's easiest to get budgets for the most obvious approaches. There is definitely more to be found in those unobvious approaches, and when we hit the ceiling with the generative AI, and we hit the ceiling soon, we will start searching broader, and there will be another interesting findings. I do believe this AI-assisted approach might be actually the future of generative AI. I'm sure every one of you worked with some ChatGPT or some other generative tool that was producing something. Now imagine that you ask ChatGPT to produce you the one acapit of texts, and you can decide on some cornerstones of this text. You change something here, you drop down some menu, you get one of 5 answers, and you say, oh, you used the first one, but I would like more the fourth one. Done. But then the algorithm, meanwhile, is learning on your choice and is affecting some other choices by that. So you don't get the thing algorithm wanted to do, you get the thing you wanted to have. Yeah, it's definitely way more difficult on the user interface approach, because like ChatGPT right now does not really have user interface. It's like prompt. What kind of user interface is prompt? So it definitely requires great user interfaces, but I do believe way more could be achieved with approaches like we did, and this could be nice tool to support our everyday work. We did some experiment with our tool. We did some experiments on humans, on game designers. They were using that tools. We were measuring results, so we could have at least 33% of speed up on their work by choosing those items from the drawer and not looking them in big libraries. So this was helpful. Also, we did survey them, and they were like in 2/3 cases quite happy with the recommendations. So this is definitely approach that could work. It has also some other possibilities, like creative designer and juniors maybe, or seniors and juniors maybe half a level could be done in the beginning by some more senior level designer. Then the algorithm could learn on that, and with that junior could maintain the art style, maintain the level style of how this is developed. So this could be definitely a solution as well. Yeah, machine learning is not always that data hungry. I'm not sure if everyone would agree that a priori algorithm is machine learning. Maybe it's not, but it's definitely an approach that we need in game. Yeah, you need this tool to be able to work on early stages of development as well. You cannot have it to rely on huge amounts of data, because bringing data from previous projects might have it to learn in the wrong direction. And what I believe also about machine learning in such approaches, that it's some kind of great averager. Oh yeah, we had one more bump that we failed to achieve. In the original project, we had this goal to find not obvious recommendations, to bring some originality to those recommendations for the designers. Fitting, but not obvious, not the first ones. We probably hoped to achieve that more with the graph approach. That was kind of failed. But then we also tried to do that a little bit with the machine learning approach, and no, it's bringing the stuff it has seen, so it's not bringing any originality. So yeah, it's great of averager in that sense, that it will be averaging everything a little bit. But also I think those AI tools could be great averager in the sense where smaller studios could catch up with the bigger studios by help of those tools, by being able to produce a little more and a little better in the same time budgets or money budgets. So if you would like to follow this journey and build that kind of tool, we're not patenting anything here. I'm here to spread the message that there are such possibilities to build such tools. So this would be the approach. Search for implementations that could work for you. Something as easy as a priori is very easy to implement in the beginning. There are libraries that you could launch and only set up the parameters of the algorithms, or how the algorithms are fed with data. You don't need to code all the algorithms. You could use maybe similar data structure. We do still believe this tagging could be working here even with the extra effort, or maybe you will have better idea with that. There could be other specific applications that we have not yet thought of. Maybe this could build game mechanics at some point and some other things. So yeah, I'm from European Union. We've been given some money. I have to show you those logos, and that would be it. I'm happy to answer any questions.
Thank you. Thank you so much. Some questions?
Thank you, bardzo, Jakub. Actually, I have a question. You describe very complex system, and have you compare the just basic procedural building of the levels with UI system? Because if you, as you say, you have not enough good data, maybe it's much easier to write a rule for procedural based level design than create the complex AI system, especially if you game rules and if your word rules is not a basic, not a realistic or such of things.
That's a very good question. We have not. The procedural generation of levels was never really in the DNA of Ice Code games. The game they are developing, level design is actually quite important there. So it was thought always as a tool to support designers in developing the levels that there were needed. But that's a good idea. I would like to do that at some point. I don't have that much experience with levels that are with procedural generations of levels. that would probably require some calculation of overheads there as well. What are the costs of building the algorithm that will be generating those levels? But that is interesting comparison, yeah.
Someone else?
Hello, thank you for the presentation. I wanted to ask you if you had tried to use some models to recognize objects and suggest text to designers to minimize the time they spend in to add some text. And my second question was, have you had a chance to record the creative process of the designers, level designers, so you may learn on, like, as you've mentioned, suggest some unique, some creative suggestions. Maybe while you're recording their process, how they are using your tool, you may then use this information to learn, to teach your system better way.
I will start with the second question. Yeah, we had like analytics system built into that, but we are not that happy with results we achieved there. Apparently, games design works for us, algorithms design maybe as well, and that was too weak on the UI side. We are apparently not that good with UIs, and we had some data out of that, but it was not very useful. Maybe because the UI that designers were using this tool at was, yeah, you could see that it was quite stinky. So that's the problem maybe here. We were looking through that data. We tried to analyze it a bit, but we haven't found anything interesting. There were some pressing matters with the project, so we decided to go elsewhere. And I'm not sure if I understand the first question about recognizing the objects.
Yeah, recognizing the object, so you may add text or suggest adding some text, textual tags to models, so designers shouldn't add them manually. Am I get it correct that it's necessary to add text to the models?
There was the visual recognition of objects was not necessary because all the objects are known in the system. You could add tags for them, so this was core of the system. You could add tags that would be descriptive if that's the case here, or bring some connections. So everything of that should work actually. I think I still don't understand.
Yeah, I just asked if you have tried or you were thinking about edit such recognition, so you may simplify designers' work even more. So you are suggesting to them tags. Instead of them adding those texts, you may like recognize, suggest to them, and like they shouldn't type in. They may select one of the suggested.
Yeah, that way. I haven't shown that on the video examples because that's not looking that great in the system, but that's what's happening here actually. So yeah, dark on dark and not very visible and not beautiful interface, but this is the place that recommends tags for the designer to add to objects. So it's another drawer. Yeah, there are numbers because it shows the strength of the recommendation, which is maybe not necessary and so on, but this is actually the place that is recommending tags to be added to an object. Yeah, sorry, that was not obvious.
Okay, more questions?
Thanks again for the presentation. Really nice. I do remember your previous about the curves, and more curves. That was funny. You mentioned that at some point you suggested your designers to use your system multiple different algorithms at the same time so they can choose the best one. Did you consider like suggesting the objects using the a priori algorithm, for example, on the early stages of the game, and then when the game is mature enough and you know that, for example, the random forest algorithm will perform better, you just swap the tool using the different algorithm?
Yeah, definitely you could do that. Also on, I think it's not a matter of how game is mature, but also how particular level is mature, how if you would consider those designing those characters or those objects, if you begin new subset of objects, yeah, you've done cowboys so far and you will be doing Indians now, probably algorithm that is requiring a lot of data like this random forest would not like this new situation because it has very little information about Indians. So maybe you should switch to a priori for a moment, produce some Indians, and then maybe go further with different algorithms. And this is also what we a little bit tried to solve with this stacking, which was kind of merging them, picking 3 recommendations from one, 7 from another, depending on the parameters that it was learning quite automatically. So that could be another solution.
And this way, like when merging results from different algorithms, you probably can also assess which algorithm performs better for this situation, right?
Yeah, exactly. We were trying to, you can do machine learning to choose between machine learnings. Yeah, that kind of approach.
Thank you.
We have time for one more question. Someone else? No one? Okay. So thank you
Okay,
so
thank you very
much.
much.